Remember, as we did last time, how do we write z-scores? Well, we said that we write z-scores by is equal to the statistic minus the mean over the standard deviation. That the z-score is actually coming from the formula of the normal distribution. But as you can see, this z-score is based on a normal distribution, a normal distribution of the population. Now, if we go into base our z-score on a sampling distribution, a z-score from the sampling distribution, then it would be the statistic, which is now a mean, right? It's now a mean, minus the mean of means, which is just the same thing as mu, is approximately equal to mu, all over the standard deviation of the means, the standard deviation of the means of the sample. And then remember that we can convert this into same thing on top, change that to mu, so the same thing, and we can convert this to relate this to the population. So it would be the standard deviation of the population, all over the square root of n, which is the sample size. The sample size is the number of things, or the number of elements you find in one sample. If one sample contains 10, then the sample size that you put in there is 10. Now, how are we going to use this analysis to apply it to what we learned last time? Alright, now what we learned last time is now our statistic. Our statistic, which is this, is now a difference, right? It's now a difference. So that our statistic is the difference between the mean, so that's an xi of x, to the mean of I. So that's a new statistic, minus the mean of the population. Now, if we're comparing it, if we're saying that there's no difference, then that mu should be 0. And all over the standard deviation of the difference between the mean. Alright, that's quite nice. And if we're saying that there's no difference between them, if we're assuming that there's no difference, then the population distribution of no difference, the mean should be 0. So hence the top should just become the mean of x minus the mean of y, all over, and as we elaborated last time, the standard deviation of a difference is equal to the square root of the variance of the x. So remember, the variance is squared, right? Plus, as we said, even though that's a minus, we've proven last time that it's a plus the standard deviation of the y's. But remember, this standard deviations is the variance of the means, right? So if we wanted to relate it to the population, then the bottom becomes, so let's put the square root here so it's quite clear. Large square root. The bottom becomes the variance of the population of x, call that x pop squared, all over its own sample size, right? So let's call it nx, plus the variance of the y population all over its own sample size, and the one on top is nothing changed. So the mean of the x minus the mean of the y. So this equation is the equation that we see in books when we're doing the t-test, right? And we will do a t-test if the sample size are quite small, less than 30, the nx and the ny's are both less than 30, nx and ny is both less than 30. If both are equal or more than 30, then we will just do a z-test. I hope you understand where this equation comes from, and we went over the different derivations and finally arrived at the stable equation that we've been using in the books. Alright, see you next time.